I'm changing the rules on you. This time you only get to draw one out. I don't know. Well, this was Grandma's cookie jar, and Grandma was being nice to you, but then you were a pain, so now you only get to pick one. Grandma ran out of bills. She let all the kids $60, and now she's going to only let one. Who knows? Okay. Well, this time, actually, it's a little bit of a game here. It's a gambling game. Okay. You have a choice. You can pick one bill. If you don't, then you have the option to put it back in and draw another one. Or you can just keep the first one. So I want the probability that the first time you reach in there, you get a 20. So you decide, that's the worst I can do. I'll put it back. And the second time, you get a 50. So what's the probability that that would actually happen? Why is it individual? It's replacement. I put it back and it's in order. You have to do it in this order. I'm putting it back in. That's replacement. You can't do combinations. This is individual. So you're going to do each one separately. You're going to go, okay, chances of getting a 20. 8 out of 14. You put it back. You're still going to times. Okay, chances of getting a 50. Oh, you did say 14. Yeah. Since you put it back, there's still 14 in there. That number stays the same every single time since you're putting it back. And yes, those would actually both reduce. 8 out of 14 is really going to go down to 4 out of 7 and 2 out of 7, which is going to give me then, when I multiply, 8 out of 49. Or we could turn it. Like I said, you can always turn these to a decimal if you prefer to look at them as decimals and percentages.
8 out of 41?
Yes, the odds would be 8 out of 41, yeah. So that was fun, that was cool, right? Yeah. So you're going to go home and gamble with your family.
Yeah. No.
Actually, you're going to go home and teach your family why they shouldn't gamble. Because the chances are horrible. Well, one other thing. We're going to go play cards. If you need your card packs from the other day out, you might want to grab your card packs. But we're going to go play cards. Okay. Actually, no, sorry.
I love playing cards.
We might be playing cards on review day if we have time. Okay. You got a deck of cards. You are going to draw one card from the deck. Okay. I'm trying to prove a point here, so that's why we're just drawing one card for the moment, because I need you to be able to common sense this. I want the probability that you will get an ace or a black card. You want an ace or a black card. Okay? And I want nobody to say anything. I want you to stop and think about that one for a second. You just pick one. So what's your chances of getting an ace or a black card?
Either one?
Yeah, you get an ace or you get a black card. But you're only going to draw one card, but what's the chances you get one of those two things?
Oh, 28 out of 52. Yeah. 28 out of 52. Yeah, 28 out of 52. 28 out of 52. That's right.
Oh, okay, that's 28.
That was an awesome debate that just happened across a millionaire. That was really great. Y'all could do that a bunch. That was like a teacher pleasure to watch that happen.
Why don't think? Why don't think?
So, I'm hearing 28 out of 52 was the group contingent plan there. Okay, so now, mathematically, how did you come up with 28 out of 52? You're right, it's 28 out of 52, but where did you get it? Okay. So, technically what you did is you said there's 26 black cards out of 52. Okay. But technically there's has 4 aces.
Yeah, but two of them are black. Yeah.
Okay, and what they're noticing is that there's black cards that are also aces, so you would be counting them in both groups. Okay, in this case, you can do what you all just did. You can just go, oh, well, there was 2 overlaps and subtract it out. What you mathematically need to do, particularly when we pick more than one card, you would say, okay, there's actually 4 aces out of 52, but then I had to take 2 away from that list. What did you actually do with these numbers? Add, subtract, multiply. Yeah, notice you were adding there, and then you have to subtract the 2 duplicates back out again because you counted them in both groups. Because when we're going to pick more than one card, if you're picking 5 cards, you would have to do each one separately and then subtract out the duplications of it. But notice you added, and what word was in there that made you add? Or. You see or, that's add. So this is the one time that you will actually add. Almost everything in probability is multiplied, but this is the one place. You see something or something, you're adding. Okay. If I had everything else is multiplied so far. So, okay, I want you to take that exact same problem and draw 2 cards this time. So now I want the probability I get an ace or a black card. I get 2, actually, I'll write it out for you. I want the probability of 2 aces or 2 black cards. Not one of each. That would be a whole nother issue to do it. 2 aces or 2 black cards. Okay, you're now picking more than one, so now you have to decide combinations or individual. So if you back up to your list, are we doing it in order? Nope. Am I saying you're going to replace them? Nope. Is it dependent? After you pick one, will that change your chances on the next one?
Yeah.
Yep. So it is. It met all 3 rules. This is combinations. These kind of problems will pretty much be combinations. Okay. So the only thing you have to do differently here, okay, I got to pick 2 aces. How many aces are in there? 4. And I'm going to take 2 of them. So this is going to figure out how many groups of 2 aces can I pick. And so then on the bottom, yes, I'm going to have 52 total, and I'm picking 2. And so that's going to figure out how many different groups of 2 cards can I pick out of a deck. And then because it's or, yes, you're going to add and go, okay, I need black cards now. And there was 26 black cards, and yes, we're still picking 2. Is the bottom going to change? No. And in fact, if you want to, if you don't want to write 52-2 every single time, I usually just put it all in one big fraction and just put one big giant combination on the bottom rather than having to write it every single time. It gets kind of annoying to write that out. Plus, you'll actually find that's a royal pain to type in your calculator. If you do that 52C2 every time, it gets annoying. Am I done? I need to subtract. What is the question? Just 2? Close, not quite. Okay. The extras. How many extras? How many were there that we counted that could be in both groups? How many black aces are there? 2. And how many of them could you pick? You can only pick 2 of them. So you still have to do it as a combination. Everything will be combinations the whole way through. And then, yeah, I would fling that whole thing in a calculator at once. And you'll find out it's 55 over 221. So that's right about 1/4, roughly. That was fun?
Are we done?
Are we done? Almost. But there's special terminology that goes with what you just did. More vocabulary. Woo! This is on your journal too. Like today's lesson is like mega journal lesson.
What number is it?
I have no idea. What you just did are what's known as mutually inclusive events. Okay, what's mutual mean? Mutual, it involves there's two people, both things are involved, but several things are involved. If it's inclusive, inclusive is included, both included the same event. So the easiest way is, there are events that share common items. They have things in common. The black aces, we counted them in both places. Okay, for example, if I had said hearts, 2 hearts and 2 black cards, would that be mutually inclusive? 2 hearts, 2 black cards. Would there be hearts that are black cards? No. So that would not be a mutually inclusive event. They have nothing in common. If I said face cards or diamonds, are there face cards that are also diamonds? Yeah. So that would be mutually inclusive. Anybody want to guess what we call it when there's nothing in common? Exclusive, yes. So if they're mutually exclusive, they exclude each other. They have nothing in common. They love to use these big whopping words, but it's really pretty basic ideas, but they make the terminology a little bit challenging. So mutually inclusive events. They share common items. All right, so now you have to actually work a problem for me. And I am...
Hey, time out, go back.
Oh, sorry. Hold on. All right, so you have here, we have 1 senior, 5 juniors, 11 sophomores, and you can see the breakdown of males and females. I want to select 4 to be on the math team, and I want the probability that I would draw 4 sophomores or 4 males. Neither of which would be a good thing. Why? If you actually want to compete on a team.
Because there's no chance
For
for,
4 sophomores, you don't have as much education necessarily or background. 4 males isn't good, because both types of brains think differently about different kinds of problems. You would want both types of brains thinking here. So you really wouldn't want either one of these. But since this is my situation, is this mutually inclusive or exclusive? Are there things in common to both groups? Are there sophomores who are also males? Yes, this is inclusive. So we would go, oh, okay, that means I got to worry about the overlaps. Okay, so I know since it's or, I'm going to do what? I'm going to add. Okay, so I got to pick 4 sophomores. How many of them do I have? 11. And how many am I picking? 4. Okay. So I pick the sophomores. It says or, so I'm going to add. I got to pick males. How many males do I have? There are 9. And how many am I picking? 4. Okay. And then, what else? Subtract. Okay. But how many sophomore males are there? There are 6 sophomore males, and I am could pick as many as 4. Okay, and then grand total, the whole thing, there were 17 of you, I believe, and we are picking 4. Now, the downside of this is I have no idea what the answer is, because we just use UActual for data. So I don't know, unless somebody's going to run that in the calculator for me. Those are too big for me to do in my head. Micah's got it. Okay. Hot dog. Thank you, Micah. Okay, while she's calculating, I'm going to write the last problem up here. Same situation, by the way.
it's 63 over 340.
63 over 340. Can you turn that to a decimal? Control.
0, 1, 8, 5, 2, 9, 4, 11, 7, 6.
Whoa. I just want 0 point what?
0.185.
185, okay. So about only an 18.5% chance we get them. Yeah, almost 0.6, okay.
Yeah.
That's close enough. Okay, this time, I just want to do the probability that I will get at least, how many do you want to do here? I want the probability that I will get at least 2 juniors on the team. Okay. These people tend to read by this. What does it mean when it says at least 2 juniors? You're still going to have 4 people on the team. Yeah. Okay, so if you see the words at least or at most, write out. One line of paper will save you a lifetime of frustration. Eric, are you with me?
Yeah, I'm with you.
Okay. But your eyes are like so low.
Well, maybe that's wrong.
Okay. Probability of at least 2 juniors, you need to write out. What can happen here? I've picked 4 people. Pay attention to the fact. You're still picking 4 people. So if I get 2 juniors, who are the others? So I'm just going to say 2 others. But since it said at least 2, it could be 3 juniors and 1 other. Or it could be all 4 juniors. Notice what word were we putting between each of those situations. It could be this, or this, or this. So you've got several possibilities. If it's at least or at most, it's going to be or this or this. There's going to be more than one set. Okay, so then what you're going to have to do, this is not going to be mutually inclusive or exclusive. This is just going to be several possible things that can happen. So we know the ors are going to make us add. How am I going to pick 2 juniors and 2 others? 2 juniors and 2 others. I'm going to multiply. Okay. Oops, I moved. How many juniors were there? 5 juniors. Remember, there's 12 others. So there's 5 juniors, and we're picking how many?
2.
Okay. Now I need to pick the others. 12 others, and we're picking 2. Okay. That's to pick that possibility. But I could have also got a team that has 3 juniors on it. So if it's got 3 juniors on it,
5 and 3.
it's 5 and 3. Notice all you're doing is changing the one number, the second number on your combinations. And that would be 12 others would be 12 and 1. And then last but not least, 4 juniors. There's 5 of them. I would be picking 4. I don't need to pick the others because we aren't doing any others. What's the bottom combination?
17C4.
Yeah, 17C4 because we're still picking 4 out of the 17. That's good because I'm out of time. And I don't know what that comes out to either. Okay, beware of